Hey guys, in this video we will learn about Go language channel. We can communicate between the two Goroutine. Another, we can actually block any Goroutine also. We don't need to use the time. We can directly block it also because Goroutine will wait particular channel to be receive the data. Another one is we can collect the multiple data on a Goroutine channel, or we can say suppose I'm running a loop of the 1000 of the number, then we want all the numbers should be processed, then a channel should close and should be written back to the main functions. So the channel is to basically effectively way to communicate. Another thing is guys, channel does not have memory. Channel is, once we write on the channel, somebody need to read it also, then only the complete communication can be possible. Let's see the practical. To make a channel, simply we can create a variable, make functions, chan is the keyword and integer is the type. We called it. To write in a channel, we can simply say channel, and this is the arrow key, and I'm writing down a number over here. So that meaning is we are writing on channel. Okay. To read a channel, we can simply write down suppose like a. So this is, we can say, reading a channel, and if I write down fmt.println, I should get the value of definitely the value over here. So will the value will get? No. Why? Because when I run this program, we'll see all Goroutine are sleep deadlock. Why? Because we does not have any Goroutine. We have this one only. So channel will communicate between the Goroutine only. Okay, channel will communicate between Goroutine. Another thing is, suppose I'm writing on the channel, I'm not reading it also. It will become deadlock. So we should be have one Goroutine, and definitely if one Goroutine will be write down, another Goroutine should read the data from the channel also. Let's make a one Goroutine. Suppose I'm making functions, print statements over here, writing down fmt dot println, and we'll say statements over here. Okay, for suppose now to simulate the process, suppose this function is taking some time, that is 4 seconds. Now this is the Goroutine, so we'll call this Goroutine over here go, and this is Goroutine. Now to communicate between the channel, suppose I'm passing the values over here. This is the value, so this value will receive it over here. So I will write down over here, suppose ch1 or any other name, chan integer. This channel, after 4 seconds, we will write down some value on it. Suppose I write down 1 only over here. After that, we wanted to read it, so we'll just simply say value, and we are reading it over here. And finally we are printing it. So now if we will run this program, it will work. So we can see we got a statement, and definitely after 4 seconds we should get the number also. So remember, channel communication between the Goroutine. Channel does not have memory. By default all the channel is unbuffered channel, means they will directly use for communications. But if you wanted to hold some value, and especially for sender, then we will write down the buffered channel. That we'll see after some time. So in example 2, we have two number x and y. So we have two Go channel. One will do the sum of it, another one will do the subtract of it. So we have two Goroutine also. One for this channel, another one for this channel. So this is one Goroutine. There we will pass these two number, and this channel. Another one Goroutine of this one subtract. It will pass, and it will subtract two number and write on a channel, and in the main thread we will read the from the channel. So these are the two functions. This is simple function guys. Whatever the value will pass, we will add it, and we will write on the channel, and we'll receive. We will write on the channel. Same thing we are doing on subtract also. Final thing is we will receive both the value of the channel over here, and finally we are actually totaling of these two channels. So guys, through the channel also we can receive the data. Means we can receive from the one Goroutine, other Goroutine, we can receive the data, and we can utilization, we can say grouping, or we can say total result conclude, we can figure out it through the channel also. So this is the way also we can use the channel. Another example is example 3. Let me comment all this thing. The next part is close the channel. Suppose we have one channel, type is integer, and we have one functions. There inside it we are running a loop. So I make downside, this is the functions, and we'll receive the channel, and we are running the loop, and we are writing on a channel. So here I'm adding on the channel. This print functions, I will use it over here. Go print, and definitely we need to pass the channel. Finally, whatever the data we will write on the channel, we need to receive it over here, and we need to print it also. So if it is run 10 times, the 10 data should become over here. New thing is, guys, after this work is done, we want channel should be closed. So for this we will use close functions. Here we will pass the whatever the reference of this channel. So channel will close and we'll get back over here. Now over here, so over here we will print it through the range loop. So this is the value we are receiving from channel. Okay, let's run it. We'll see we got an output of the 0 to 9 exactly, right? So this is the way we can close the channel. So if we have some work, after that work is done, so that time we can close it. I can go with the normal loop also, then I need to be run the infinite loop, and over here I need to be check like it. Channel will give us to the OK and the value. OK means if the channel has the value through the loop, we can get it also one by one. If the value is actually over, we can break it also, because it is running infinite. We can check like it. Or either we can use the rate, because if we have the multiple channel we are writing down, it behave like a collections. We can receive all the value over here. So both is the fine. So this is the way, guys, we can close the channel. The next one is directional channel. So we know that channel means two-way communications, means two go routine, means one we will send the data, another should be receive it also, means reading and writing should be sync, otherwise we will get the deadlock actually. So whatever we used it till now, it is actually bidirectional, but we can make it a send only channel also, receive only channel also. This is bidirectional. So what we used it earlier. So this is a channel, we are sending the value to the channel and we are receiving the channel. But if I need to make the send only channel, then I will make it like a way. So this arrow will become, earlier we does not have, but here we have the arrow over here, right? So meaning of this one, we are sending it only. And if I need to make the receive only, then I will make it like so. This arrow will be goes to there, means its arrow will be around the right hand side, that means actually sending, and left hand side means actually we are receiving the value. So this is the way we can get the value. So let's see the practical. We have one channel, that type is integer over here. We have one function, there we will write on the channel. I can say a function send the number to the channel. So we are sending over here. And what is the type over here? We have the send only. So this goroutine, we will call it over here like a way. So this goroutine is the only work is to write down on the channel only. That's it. And after the work is done, then we are closing the channel. Now we need to require one more receiver functions. So this is the receiver function. It will receive the value and just print it value. This is not goroutine. This is normal function. It will receive a channel and normally it will print it also. Sometime we need to be required the unidirectional also. Why? Because we want to safety, we want to prevention of the error, avoid incorrect uses. Sometimes we want to be achieve the encapsulation abstraction also, then we can use it also. And sometimes we need to be use the achieve the concurrency pattern, then we can use it also. So for example, if the producer generated data and sent to the next stage, and processor receive the data, process it and send to the next stage, like it means it's just sending the data to the further actually. One is the receiving, another will sending. So this channel will work out to just send the data, not for the receiving data. Let's run it also. If I run it, I got it this number, because I actually here I'm printing 0 to 5 and here we are receiving all the values over here. The next one is we have buffered channel. So till now what we made it actually all are the unbuffered one. Buffered means we need to give some capacity to this channel, how much buffered it can be stored. It means look like as a memory. Sender can send the data in a buffered till the time it has the capacity. We does not have an issue, means the capacity is over. If you will send the more data, then it will block. So buffered channel will be till the time we have the space, we can send it actually. Receiver can receive one by one value, but it might be actually sometime receiver is doing some processing and it will take time. So till the time we have the buffered value. So over here, for example, I made a one channel and this is the capacity 2. So meaning of this one, I can send the data. So example, I'm sending this one, another one I'm sending on over here, another value. So guys, buffered channel means we can store the data on it and we can receive the value over here. As I told you earlier, channel does not have the memory, but in buffered channel we can store the value. So if I run it this one, so I will get the value 1 and 2. So this is the benefit of the buffered channel. Let's see another example, capacity 3. And we have one function, that name is called producer. In this producer functions, we are running a loop. This is the loop and it's run 5 times. So in this channel, we are actually adding the value, means writing on the channel one by one. So it's running 5 times, 0 to 4, and we will write down the value on channel. And parallelly, we are printing it also. Finally, once this loop is done, we are closing the channel. So producer work is done. Now the consumer work will start. In this consumer work, so consumer means it will consume the value and we are getting the collection of all the channel value. Over here it will consume, and to simulate, I'm just for 1 second, I'm just delaying it exactly. Okay. Now let's see how it will work. So let's run it. Now you can see here I'm sending the values, and what is the capacity? We have the capacity 3. Okay, so that means it can be hold the 3 values. So it will get 3 values, sent it, and 4th value, once we receive the 4th value, we will get it back it also. But 5th value won't be sent. So once it will receive, then this blockage will be the free, means the buffer is free. Then one by one, it's slow, actually receiver is slow. So receiver is actually working slow, and sender is actually sending as the buffer is free. So once another buffer is free, then it will send it till the time it will block it. So this is all about, guys, buffer channel. It is very useful in concurrency. Another example is, suppose we have a channel of integer, and same thing what we did earlier also, we have consumer also. In this consumer we will pass the channel, same as we have producer and consumer. In the producer we will pass the channel, and consumer is just consume the channel and print it also. So this is consumer functions. So over here, whatever the channel collection will get it, just simply print it. So this was the producer functions, and we are printing the 100 value on the channel. So over here, suppose every channel is doing some work. So to simulate, I'm just actually making one functions, and for 1 second it will pause it, and after that it will generate a random number between 1 to 100. This value we will actually write on a channel. So we'll receive the value over here, and this value write on the channel. Right? So this is the way we can do, and this is the almost similar example what we did the last time. So when we run it, we can see one by one loop goes to there, work is assigned, it will wait for 1 second, random number generated and printed over here. So these data will be get it over here one by one. Loop is running continuously, right? And value is receiving over here one by one channel, right? It's very slow process, guys. But as we know, Goroutine is very fast. So to make the fast, in this situation, we need to use the wait group. So wait group and worker pool I explain in the next video. There will see some example of the how to make the worker pool also. So that's it, guys. This is all about the channel. Thank you, guys. Have a nice day. See you in the next video.